Okay, so welcome everyone to Guided Study Group week 3. No, week 3, yeah, of Statistic 100. So, as usual, we're gonna go through the material. So this week we're gonna do working on lesson 4, getting the big pictures and summaries. So kind of like trying to demonstrate and display the data in graphs and try to like actually draw some conclusions out of it. So before we get to the data display, we're going to talk about evaluate and research studies. So this is kind of like a mandatory step for every kind of research, for every study that you're going to do in the future, regardless if it's like experimental or is it observational or is it a sample survey. It doesn't really matter, but always there's going to be a step that you have to step back and look at the result that you have and evaluate if it makes sense or not. So the kind of like the process to evaluate research studies and also like coming up with the correct method to do it is that first you determine the type of study conducted. Is it a survey, is it observational study, or is it a randomized experiment? Then we have find out what exactly is the questions that you're trying to answer. Say if you want to study the effects of height, or if you want to study like some characteristic, identify it here, and also any kind of confounding variable. Say if you're constructing that studies to try to like see what is the effects of one factor, but then what are some of the other variable that can be involved during the process. So kind of like just give us a head, like an expectations of, okay, how accurate can our results can be and what can make actually affect it. Then we have check the difficulties in disaster. So even though we have the study idea in our mind and how we're going to do it, you should actually review the common mistake of each type of study. So see like, okay, so consider the choice that you already make. Is there any adjustment that you need to make for your study before you start it based on these common mistake of each type of study? And say if you're missing any critical information, find it by tracing back the report or the original sources. Then after that, you do the study. So like do the experiment or observational study, then evaluate the result. So is it scientifically sound? So you're going to look at the result, and particularly you're going to see like, okay, what's the significance of each type of errors and how each factors is going to affect your result and all of that, which we're going to talk more at when we comes into the following weeks. Then we have say think of any other alternative explanations for the result of this that we have. Say like, except for our variable, is there any other variable that can affect it? So again, it's kind of like similar to what we think at the beginning, but now we have more data to base our conclusions and kind of like our speculations. And then finally, we consider if the results are strong enough or robust enough to kind of like change your further decision. So say if you have you study the fact that if you eat too much or like don't exercise, then your weight is going to increase and also all the risk of the illness. So is that study going to be strong enough to affect your future behavior with like eating and exercising and all of that? Now we talk about graph. First of all is we wouldn't actually talk about like how you're going to consider all of that. It's going to come from mostly your experimental experience. So like what you're going to encounter in your life depending on your field of study. So that part is going to be a little bit out of scope. The main focus of statistics is more like you demonstrate the result and be able to like represent it in different ways that can give you some meanings. So here we have graph and data, and it was a lot of way to like demonstrate your results so that you can see like a trend or like some meaning behind it. So we have things like dot plot. So dot plot is where we have here. This is dot plot. So kind of like it shows like each individual as a dot, and depending on their rate, on their value. So here if we have the rating from 0 to 10, each dot is like an individual in the survey that we're asking that actually give a rating, and this is their rating. Based on that, you can see the fact that this distribution has a very high rating, and very few people actually rate it very low. Then we have something is the stem plot. So the stem plot is this way, where you get, like, say you have 40 for 31, 39. You just take the first number out and you're gonna start rating all of them on their uh based on their value. Then we have histograms. So histograms is more like a very common one to use, and this is because the fact that it, instead of represent each of them by their own value, they actually put them in ranges. So say here, if you have, see, like each range over here, so this one is 40, this is going to be 36, and then each of them is going to be, each range have 4 units in there. So this is going to be from 30 to 34, 34 to 38, 38 to 42, and all. Let's just come up, and it allows us to represent more values and approach a bigger set of data. So this is where we have histograms. That's how histograms become more common. If we have a bigger set of data, usually the approach that they have is that they're gonna make each column with bigger range of values, so that you can represent more values in each column, and you can like accommodate a bigger set of data. So the width depending on the range of value. The skewness. So here, if you look at this, it doesn't have the symmetric shape of like a bell shape, but it's more like leaning to the right. That's how we call it skew to the left. That's a little bit weird, but it just say that if you see it's going to the right, like more, the frequency on the right is higher, then you call that skew to the left. And if it's this way, you're gonna say that skew to the right. And the symmetric is, of course, is a perfect bell shape. We also have something like a bimodal. So say if you have a histogram like this, it can have shape like a bigger a peak here and another peak over there. So it's usually applying, say, things like you say surveying the average height of American, regardless of their race and not regardless of their gender. But if you want to demonstrate it, you're gonna see two peak. So the small peak, the first peak might be like the height of most women, and the second peak is like the height of most guys. So yeah, most men. So that can be one of the example. After we represent it on graph, there are also some other parameters and statistics that we use to demonstrate a characteristic, say like the central tendency of your data. So we have two kind of measures of center and measure of spread. So basically see like what is the center of your population's data. So say maybe like the most popular values, or like the range of most values that have the appearing. So we're gonna have things like mean, median, and mode. But mean, we're just mostly based on mean and mode. Mean and median. So the mean is kind of like basically just the numerical average. So when you have like 5 values, you just like they sum together and divide it by 5 to find the average. And it's a sensitive measure. I think if you look at your lecture notes, you can see the fact that it's gonna be affected by if you have any outliers or like any unexpectedly big or small values. The mean is gonna be affected more than the median. The median is the 50 percentile, and to find the median, the best way to do it, and I would say that's like the only way, is to just put all of them in an order from smaller to biggest and pick the middle value. And it's a resistant measure, so it's usually the one that kind of go against some of the outliers. So the value of the outliers doesn't really matter, it's just the order. So that's why we said the median is the resistant measure. And which measure to use is depending on your distribution. As I said, if you have outliers, obviously median is a better representation. But if you have like a symmetric, nice histogram distribution, you can feel free to use the mean. We also have something called a 5-number summary and box plot. So the 5-number summary is basically just pay attention to 5 specific values in your set of data. And to do that is you have to put all of them in an order first, from smallest to biggest. So the minimum is gonna call the 5-number summary, including the minimum value, maximum value, lower quartile, upper quartile, and median. Now median, we know that minimum and maximum, very clear what is the minimum and maximum value, and also the lower and upper quartile. Now the maximum value can be the outlier and it or not. It doesn't have to be an outlier if it doesn't make sense with our the most of the value, if it's too far from most of the values of the data set. We also have things called lower quartile and upper quartile. It's basically the value that stand at the 25% of the population. So 25% of the population is smaller than this value. And similarly for the upper quartile, or 75%. So yeah, so this is the meaning of that, and this is what we call the box plot. So the box plot basically consider like a box in the middle with like a, I don't know how to say it. It's like a stick in the middle. It's going to be the value of the median. The two ends of the box is going to be the lower and upper quartile, and the two stick that stick out of the block of the box in the middle, it's going to be it's going to head towards the minimum and maximum. And in the box plot, you sometimes see it's like, most of the time actually, you're going to see it in this vertical shape with some like asterisk below or above. These asterisk, like here, oh no, not this one, are the outliers. So to identify if it's outliers or not, it's more coming from the like calculations and all of that, but mostly you just, because in this class we just focus a lot on the conceptual thinking. You guys don't actually have to like figure out how to calculate those and find the outliers. Mostly you're just going to be given like a graph, and you're going to be asked questions about how do you interpret the data. So box plot, you can see the median here, which median is bigger, so you can make conclusion about the center. You can also look about the amount of spread, which we're gonna talk later, but mostly just like how long each of the box is. So here, the spread of the second set of data is much smaller than the bigger one, just based on the length, which means your data is spreading on a bigger range, and this one is just on a small range. What is the shape of the histogram? So it's kind of like not 100% here, but you can clearly see, like if you have a histogram here, the median is slightly closer to the upper quartile, so it's a little bit skewed to the left, but this is the overall range. However, if you look at the second quartile, second box plot, then you can see that it's very dense together, and the median actually closer to the lower quartile, so it's going to be something like this. So like, yeah, so it can give you like a general idea of what is the shape of the histogram. And then finally is the number of outliers depending on how many asterisks that you're given. Yeah. And then we have things like the measure of spread. So basically, as I said, is how spreading out your data set is. So like if you have a result and you see like if it's spreading on a big range, it includes a lot of values, or is it just accumulate in a small range of value, just like the box plot that we see. And we have things called a standard deviation. You guys don't need to like care much about like how to find it, but mostly the thing that you need to know is this a sensitive measure, similar to the mean, because it's account for. So to find the mean and standard deviation, you have to account for every single value in the data set, which means that you also take care of the outliers. So if the outliers is very far from like the majority of the data set, it makes your mean and standard deviation be much more different than what is the actual central tendency. And so kind of like an equivalent to standard deviation is what we have the interquartile range. So as we mentioned, the range, the interquartile, everything related to like the 5-number summary. It doesn't really matter much about the magnitude, but it's more like the order of that value. So as long as you can put them in order, usually the outliers is going to be near the maximum or near the minimum. And so it doesn't really affect the Q1 and Q3. An interquartile range is 5 by Q3 minus Q1. Which measure to use? Depending on, again, on outliers and histogram distribution. If you have a symmetric population, then mostly you can just use mean and standard deviation. But you have a skew, like a skew distribution, usually you're going to use just median and interquartile range. Now, let's do some practice questions and problems. So if you're joining me online or like rewatch this video, please feel free to like stop me, like mute me or like stop the video to work on these on yourself, because I'm just gonna give out the answer now because no one's actually joining me online. So let's get started with the first questions. Which of the following cannot be determined from a 5-number summary of data set? A is lowest minimum value, B interquartile range, C mean or numerical average, or D lower quartile. So we all know the fact that the 5-number summary including the minimum and the lower quartile. Now between B and C, the interquartile is found by Q3 minus Q1, so you can find that as well. So what we cannot find is what exactly is the median, because the interquartile range, no, the 5-number summary only give us 5 values in our data set. But to find the mean, we need all values in the data set. Now, question 2. Again, feel free to mute me if you want to work on it alone, and I'm going to just give out the answer here. Which of the following has an IQR of 0? So, before we find what is IQR, we have to put them in an order first. So let's put -3, -2. So the first one is already in an order. So this one already in an order. Second one, there's only one value. And the third one, let's put them in the order. 28, 40, 56, 61. And this one is already in an order. Now let's find the IQR. It's lucky for us that here we only have around 5 or 6 values for each. So we can easily find what is their IQR because we can identify their Q1 and Q3 immediately. Here in question 2, you have Q3 minus Q1. So we cannot really see what is Q3 minus Q1, but it's somewhere around -2 and then -2, -1, and 1 and 2. So our IQR, if you let this value over here minus this value over there, it's gonna be something different from 0, right? Because it's 2 different values. On the other hand, if you have B, you have Q3 equal to Q1 equal to -1. So this one is gonna be equal to 0. That's our answer. Now let's look at the rest. This one is Q3, this one is Q1. And so the IQR here is 28. And then the last one, this is Q1, this is Q3. So we have this one's going to be 19. So yeah, B is our answer. Pretty easy, right? It's not that much of calculations at all. It's just as long as you understand what we're trying to find, then you'll be good. So let's go to question 3. So question 3, again, please feel free to mute me if you want to work on it alone. Suppose every baseball player is fined $10,000 after a pro clears the benches. I don't actually know what it means, but just say that. Which of the following salary statistic for the game would change as a result? So basically, we're saying every baseball player is fined $10,000. So their salary is decreased by $10,000 for each of them. Now, it's asking which of the salary statistic for the game would change as a result. Now, if we have a range of value, so a ton of value, and then you have Q1, then you have the median, then you have, there's some values in between as well. Of course, you have Q3, then you have some value, and then you have maximum. Now, when you have each of them divided minus $10,000, so you have minimum minus 10K, Q1 minus 10K, median minus 10K, Q3 minus 10K, and then maximum minus 10K. Now, let's look at the answer choices that we have. So the median definitely gonna change. So it's A. Interquartile range. So IQR is the new Q3. So I would say Q3 bram minus Q1 bram. So which is gonna be Q3 minus 10K minus Q1 minus 10K, which is gonna be equal to Q3 minus Q1 or the initial IQR, right? So this is not changing. The next one is standard deviation. The standard deviation is just how spread out the value is. So if you just think about it, like at first you have this kind of, say, this is the set of value. Now you move it 10K to the left because all the value decreased by 10K. So it's not a very similar graph, but basically you just shift it. So the standard deviation doesn't really change, like how spread out the data set is. So it doesn't change. So this one is not changing as well. Basically, you just shift it. Then you have the range. The range is from here to there. So the range is going to be maximum minus minimum. So let's find a new range. So the new range is range bram minus is going to be max bram minus mean bram, right? New max and new min, which is going to be max minus 10K minus min minus 10K as well, which is going to just give us max minus mean or the original range. Again, range is just another parameter to show us how spread out is our value. And if we just shift it and we don't just like change one single value, we change every one of them by the same value, the range is the same. So this one doesn't change as well. So our answer is A. It's kind of like a challenging one. That's why I really liked it. If you want to like find more of these, I actually picked them out from Canvas practice problems. So feel free to have a try on all of them. I think it's like 35 questions, and I think most of them are really helpful. Now, let's see how many questions do we still have. Oh, let's start on 4. So again, please feel free to like stop me online if you rewatch this video. If not, then we can just continue. Question 4, which of the following statement is true? Hint, draw pictures. A, if a dataset is skewed to the left, that means there's bias in the result. The data are lower than they should be. Okay, so all of them is talking about data skewed to the left. This is what we call skewed to the left, right? So there's bias in the result, and well, I mean, if it's skewed to the left or not, I have no idea if it's have any bias or not, because the bias is depending on how we do the experiment and how we choose the data. So the data itself cannot tell that it's biased. It has to come from the decision that you make before you do the study. So this is wrong. Now looking at B, if the data set is skewed to the left, then the higher values are more spread out than the lower values. So this is the higher values, and this is the lower values. You can clearly see the fact that all the higher values are very accumulated compared with the lower value. So this is also wrong. The high value has a very high frequency, so there was actually very dense together. So the lower values are actually more spread out than the higher values. So the answer is C. Again, I would say the hint is very helpful when you draw the graph, and of course it's only when you draw the right graph. Now let's go to question 5. If the width of the box in the box plot is very small compared to the rest of the box plot, what does it mean about the shape of the data set? So the width of the box in the box plot is very small. So I would say like here, you have it's pretty not clear. Like that. So here you have one box plot, it's very small with the width, and one is very long. What does it mean about the shape of a data set? So it only means the fact that these values are very tight together, and the rest is the Q1 and Q3 is very close together. So which means that you have a very skew this way. If you have, say, like if you have like another shape with different, give me a second. If you have another shape with another color, say like this, then Q1 is around here and Q3 is around here. But here you have a smaller one, a very narrow peak. So you have this is Q1 and this is Q3. Therefore, we have the data very spread out from the middle. The data are very clumped tightly in the middle. So that's the answer is B. The data are not symmetric. Okay, there's nothing we can conclude. Not enough information. And then the data are symmetric, again, not enough information. What if this box plots show that the data set is skewed right? What is most likely the relationship between the mean and the median? So now, when it's skewed right, okay, skewed right is this way. So that's gonna give us the mean is gonna be over here, and the median is over here. Why is that the case? So it's because the well, actually, let's think about it. Good questions. I don't know. I'm not quite sure about this part, because if we draw it out, median is the one usually is the central most, and the mean and the median. So if it's skewed right, you're gonna have more of the small value. So this median actually. Okay, it's the other way when you have, if you look at the online note. So because when we have a skew right, so most of the value is gonna be very smaller than the central median, the central average. So it's gonna have a lot of the small values and less of the big value. But in the mean, you have to account for all of them. The median, you only care about the order. And if you put all of the numbers in order, you're gonna have a bunch of the small numbers in here. So you're gonna have the median is going to be smaller than the mean. It's because the median is going to just account for the small numbers that have a very high frequency, but the mean is going to take all the numbers into. So it includes the big tail over here as well. So the median is going to be smaller than the mean. Again, there are going to be more specific explanation and more detailed explanation on the notes online. So I wouldn't really kind of like repeat all of them here. Now let's go to question 6. Again, stop me if you want to work on it alone. Question 6 is asking, if we have a 5-number summary of this, what is the percentage of the data between 5,500 and 1,375. So that's where we actually come to remember what is the meaning of the percentile. So the minimum is, on the other hand, is can be called the 0 percentile. So it's the smallest. So 0% of the population is smaller than this value. And here Q3, well, which is the 75 percentile. So 75% of the 75 percentile. 75% of the population is going to be smaller than this value. So between minimum and Q3, it's going to be 75% of the population. So it's going to be C. So pretty easy, but it's only when you understand the meaning of percentile. Now we go to the last questions. Given the box plot below of the starting salaries, which of the following statement is false? So the data set is skewed, right? Okay, so now we're just looking at the starting salary, right? We have a bunch of big outliers. So say if we about to draw the histogram, if it's skewed right or left, it's just depending on how close the median is compared to the upper and lower quartile. Here, if you look at it, the median is slightly closer to the upper quartile, so it's this way. So it's actually skewed left and not skewed right. Skewed right. So this one is wrong. Then B, the minimum is approximately 8,000. Yes, likely smaller than 10,000. So this is correct. The median is approximately 26,000. So if you draw it out, it's slightly above 25,000 as well. So this is correct. The IQR is approximately 15,000. Now you have to think about what is Q3 and Q1 to find it. So I would say Q3 is around 30,000 and Q1 is around 20,000. So I would say the IQR is around 10K. So A and D are kind of wrong because the IQR is just around 10K. And I think it might be one of the it's actually, let me ask your professor again, but I'm pretty sure like both of them are wrong if we just look at this graph. But yeah, that's everything we have for today. And if you have any questions, please feel free to email me. Final note, weekly review session is available on my YouTube channel, so please watch it. The next review is next Thursday at 10 p.m. Eastern Time, and I would highly recommend trying out the practice problems on Canvas. So, if we don't have any more thing, I'm going to end the sessions here, and I'll see you guys next week. Have a great weekend, guys.